Lesson 7.2, Task 1. Inverses of quadratic and cubic functions. Alright, find the inverse of a many-to-one function. Some functions have the same value for different values in their domain. These functions are called many-to-one functions. Many-to-one functions do not have inverses that are functions. If the domain of a many-to-one function can be restricted so that the resulting function is one-to-one, then the inverse over that restricted domain is a function. All right, so remember a function, something is a function if all the x's are unique. All right, so it says the function f of x is defined by the following ordered pairs. All right, so this is the ordered pairs, and we can tell it's a function because 7, 8, 9, 10, 11, 12, 13, those are all unique. If all the x's are unique, then it's a function. All right, so it says, what is the inverse of f of x? Select all that apply. All right, so to find the inverse of an ordered pair, you simply switch the x and y. So the first ordered pair would have an inverse of 22, 7. The next one would be 7, 8, negative 2, 9, negative 5, 10, negative 2, 11, and 7, 12. And 22, 13. All right, it says, is the inverse of f of x a function? All right, so let's see if all the x's are unique. 22, 8, 7, negative 2, negative 5, negative 2. Negative 2 shows up twice, 7, 22. And 22 shows up twice. So since the x's are not unique, the inverse is not a function. All right, so it says, is the inverse a function, yes or no? Then justify your response. So the answer is no. The input 22 has two different outputs, a smaller value and a larger value. All right, so let's look at the input. That's your x value of 22. Your input 22 has a 7 and a 13 as output. So the two different outputs, the smaller value is 7. And the larger value is 13. All right, it says restrict the domain of f of x to only those ordered pairs that have values of x greater than or equal to 10. So now we're only going to look at the ordered pairs that are greater than 10 in the domain. So 10, 11, 12, 13. What is the inverse of f of x with the restricted domain? Enter one ordered pair per line and enter answers in order from lowest to greatest x's, which means your domain. So we're going to start at the left and just work across. So the inverse of 10, negative 5 is negative 5, 10. The next one is negative 2, 11. The next one would be 7, 12. And the last one would be 22, 13. So all we had to do to find the inverse was switch x's and y's. Is the inverse of f of x with the restricted domain a function? All right, so if we look at the x's, negative 5, negative 2, 7, 22, those are all unique. So yes, once we restricted the domain, now it is a function. All right, that's all for task 2. We're going to move on to all for task 1. We're going to move on to task 2. Lesson 7.2, task 2. Inverses of quadratic and cubic functions. The square root function. All right, it says quadratic functions are many-to-one functions because there are numerous pairs of values of the independent variable whose function values are the same. For quadratic functions, f of x equals x squared, the domain can be restricted, so the inverse is a function. All right, so restrict the domain of f of x. All right, so you can see that some of this is cut off over here, so it's in the textbook as well if you want to follow along. The first line where it says restrict the domain f of x equals x squared for all x, such that x is greater than or equal to 0. So we're just going to look at the positive values of x. All right, then you're going to replace f of x with y. So we're just going to take this was in function notation and we're going to replace it with y so that we can switch x and y and solve for the inverse. All right, once we do that, we're going to replace this now with inverse function notation. F inverse of x equals the square root of x for all x such that x greater than or equal to 0. So remember, we restricted the domain at the beginning. It's still going to be that as well. All right. Now it says notice that only the positive square root was used in the inverse function. The domain of f was restricted to non-negative values. So the range of f inverse will only have non-negative values. The inverse of the restricted function f is f inverse equals the square root of x. All right, so it says the inverse of the parent function f of x equals x squared for all x such that x greater than or equal to 0 is the parent square root function g of x equals the square root of x for all x such that x greater than or equal to 0. In general, the inverse of the quadratic function is the square root function. All right, number 2 says the table shows some values of f of x and its inverse function for the domain x greater than or equal to 0. All right, so you can see that there's positive values of x, 0 and numbers greater than 0, and they're going to square those. F of x is x squared, and then it says g of f of x. We learned this in the last lesson, and this is a composition of functions, and if you put x into one function, put the answer into the second function, and you get what you started with, that means it is the inverse. And you can see that they've done that there. All right, so it says, what is the range of g of x equals square root of x? So the range would be greater than or equal to 0. All right, is g of x an increasing or decreasing function? All right, it's going to be increasing because we're going from 0 and numbers greater than 0. All right, it's also a positive function. Did I spell increasing wrong? Dun, dun, dun. Let's try that again. All right, that's better. All right, it says, what are the intercepts of g of x? All right, it's going to be, if you look at those on the graph, you can see that it's going to be 0 for both of those. And you can just take a calculator and graph x squared, and you can graph square root of x. Let's see here. Don't know what it wants me to do there, so let's look at this. Select the arrow to show the correct graph. All right, so this is the square root function. So it starts here and it goes sideways. Remember, a quadratic function is a U-shaped graph called a parabola. It goes this way. If we turn it sideways, it would be a U-shaped graph sideways here, but we restricted the domain to only the positive numbers. So that's why it's only half of the quadratic. All right, it says to confirm that g of x is the inverse of f of x for values greater than or equal to 0. So you can do the composition of functions to see that, or you can graph this and see that this is all the values for x squared, where x is greater than or equal to 0. And this is your square root function, where x is restricted to x is greater than or equal to 0 as well. Remember, an inverse is the reflection across the y equals x. This is y equals x, and if you switch the x and y, you can see that those would be inverses of each other. All right, so you can visually check that, or you can check it using compositions of functions. All right, that's all for task 2.